Dear students, in the last video we talked about position, uh, path length, and displacement. Now in this video we will be talking about average velocity and average speed. Okay, so firstly, average velocity may be defined as or average velocity is symbolically written as v bar. V for velocity, bar for average. So v bar is equals to delta x divided by delta t, or like in words it is written as average velocity is equals to delta x as your displacement divided by delta t is your time interval. So average velocity is displacement by time interval. Or it is further broadened and written as v bar is equals to displacement is x2 minus x1, there is final position minus initial position divided by delta t is time interval, so it is final time minus initial time. So this is your average velocity. So average velocity basically okay, so inside this average velocity we will be talking briefly about position time graph. So the y-axis I have put or x, that is position on the y-axis, and t time in the x-axis. So if I draw this kind of graph here, see, look, this time of graph, then what this graph will signify? So this graph will signify, see what is happening in this case, x give me position, so this is the position, let the position be 5, and if you see closely, what you see is at 0 time, this is time, so at 0 time the position was 5. Let us take at any other time, that is t, and at any other time 1, the position itself now still it is 5. At any other time 2, the position still is 5. That means at all time, let's say time is in seconds and position is in centimeters. So at all times, as the time changes, 1 second, 2 seconds, 3 seconds, but the position of the particle or the position of the body do not change. So we can we can conclude that the body is at rest. The body is at rest because in this case the position is not changing with time, or we can say this graph to be graph for the stationary motion. So stationary means it is a state of rest. If the body is not moving, we call it to be a stationary motion. So this graph will give me this graph is your graph of the stationary motion. Similarly, if you have this kind of graph, see, okay, see this one. Okay, we'll talk about this later on. Okay, let's do it right now. This side time, this side position. Okay, this is if your graph looks like this. So in this graph, what is happening? As the time changes, this is 1 second, 2 seconds, 3 seconds, this is 4 seconds. The position coordinates are changing as 1 centimeter. This is 2 centimeter, 3 centimeter, 4 centimeter. So if you look closely to this kind of graph, you see with time, at 1 second the position was 1, at 2 seconds the position was 2, at 3 seconds the position was 3, 4 seconds the position was 4. So what you see is the position of the body is changing with time. As the time passes, the position changes. But also you can see here that with equal time interval, equal distance is covered by the object. For example, between 0 and 1 second, that is one time interval. So that time interval is basically 1 second. So between 0 and 1 second, the distance traveled is 1 centimeter. Similarly, between 1 and 2 seconds. So between 1 and 2 seconds is the time interval of 1 second again. So in that 1 second, the distance traveled is again 1 centimeter. In another 1 second, the distance traveled is 1 centimeter. And another 1 second, the distance traveled is 1 centimeter. So for each equal time interval, equal distance is covered by the object. So such kind of graph, or the graph basically give a particular kind of motion, and that motion is your uniform motion. So this motion signifies your uniform motion. So I've talked about two position time graph. First one is for the stationary motion, where the distance do not changes with time. So this is one position time graph. Another position time graph is of uniform motion, where equal time with equal time interval, equal distance is being covered by the object. Now there is a third type of position time graph, and so it looks like this. Actually, it looks like this. Okay, it is a curve. Basically, it is a curve. And if it is a position in this side, and if this is seconds or time in this side, so if you look closely in this graph, then you can see what you can see is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So this is 1, this is 2, this is 4, this maybe 6, this may be 9. So I have given this coordinates random numbers, and it is valid because the gap, see, the gap is being widened. The gap is smaller here, the gap becomes greater, the gap becomes greater, the gap becomes greater, the gap becomes greater on the y side. So what does this mean is, between this first 1 second from 0 to 1, the distance traveled was 1. But okay, again from 1 to 2, okay, let us take the distance traveled as 2.2. This will be not 2 exactly, because this is a curve, so distance traveled will change. It will be not 2, but it is 2.2. From 1 to 2.2, the distance traveled is 1.2. Again for 2 to 3, that is again a 1 second. So in that 1 second, the object will travel a distance from 2.2 to 4. Okay, again the displacement or distance traveled changes. From 3 to 4 seconds, that is a time interval of 1 second again. So in this time interval, that is 1 second, distance traveled is 2 here, 2 centimeter. And in the last time interval, that is again of 1 second from 4 to 5, the distance traveled will be 6 to 9, that is 3 centimeter. So in this case, with each equal interval of time, the distance traveled are not equal. So such kind of motion is known as non-uniform motion. And the position time graph for non-uniform motion is this one, where the distance traveled with time are different. Now let's look more closely to the position time graph. Let's look more closely to the position time graph. First one, stationary motion. So this side is position, this side is time. So the graph for stationary motion is this one. So now let's see what is the slope of this particular line. So the slope of this particular line is change in y-axis divided by change in x-axis. Okay, but change in y-axis is nothing but y-axis is being replaced by x, so this is change in x. So y side is replaced by x, so change in y is change in x divided by, in x-axis I have given or I have put time, so change in x-axis is delta t. So slope is change in x-axis divided by change in time. But what is this delta x by delta t? We have already defined this delta x by delta t as our average velocity. Okay, so average velocity is nothing but it is displacement by time. So delta x is your displacement in this direction. Displacement means it is the difference in the change in position of the object divided by change in time. So this will give me average velocity. So we conclude here in this particular case, or for any of the graphs, slope in the, this is a note for you, slope in the position time graph will give us the average velocity. So slope in the position time graph will give us the average velocity. Okay. Okay, so let's find the slope. What is the slope in this case? The slope in this case is change in x by change in time. So for change in time, for change in some time, for some change in time delta t, there is no change in positions because this is a stationary motion, the object is at rest. So change in position or displacement in this case is 0. So slope is 0 divided by change in time interval is delta t. Okay, for some change in time the change in position is 0, so slope will be basically 0. Hence If slope is 0, average velocity will be 0 or v bar will be 0. So for this type of position time graph, which gives us the stationary motion, and the slope will give us the average velocity, and in this case the average velocity is 0. Now for uniform motion, for uniform motion again, slope will give us the average velocity, same thing, same concept. So slope is delta x by delta t, which is your average velocity. So in this case the average velocity will be some change in x divided by some change in time, because here for the change in time, for example from 1 to 2, the position also changes. Let us take for example, for change in time interval from 2 to 1, that is 2 minus 1, t final minus t initial, the position changes 2 minus 1. So average velocity is 1 by 1, that is 1 meter per second, or if this is in centimeter, if this is in seconds, so it is 1 centimeter per second. Okay. So this is it for today, and now I'll give you some homeworks. So the homeworks for today will be for the following graphs of uniform motion. So I'll give you the graph of only uniform motions. For the graph of the following uniform motions, find the average velocity. Okay, so the first graph is this one. So this is 5, 4, okay, this is 3, okay, this is okay, it's fine, and okay, so it is a little small graph, so I'll give you a bigger graph for the same uniform motion. Okay, in a new page, I'll give you homeworks in new page. So homeworks are okay, so this is time in seconds, this is positions in centimeter. So the graph is this one. This is 1, this is 2, 3, 4, 5, and timer. This is 1, this is 2, 3, this is 4. So find V in this case. Another one is zero. So 1, this is 2, this is 3. So these are in seconds. That is time. So time is in seconds. And these are positions in centimeter. This is positive, this is negative. Okay. This is negative x, this is positive x. So this is 1, this is 2, this is 3, this is minus 1, this is minus 2, this is minus 2. So your graph looks like this. So minus 2, 2. Okay. Okay, it's also again a messy figure for you, so homework number 2 will be this one. So I want to draw a beautiful picture. X. Again a mesh. Okay, I'll do this way. Then, okay, suppose this is time in this direction in seconds, and this is positions in centimeter. This way, this is negative x. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is 1. This is 2. This is 3. So this side is position, and this side are time. Okay, so looks like this, something like this. Looks something like this. Okay. I'll give you a short hint about it. So at 3 centimeter, at 3 centimeter, that is positive 3 centimeter, at this 3 centimeter, no, this is my time. Okay, at 3 seconds, your position was at this particular time, the position was 2 centimeter. Position was 2 centimeter, but at time equals to okay, this may not be correct. Okay, this may not be correct here, so just do the first homework and submit it. Thank you.